Thanks everyone for coming. So let's start with a quick survey. Who among you knows what HomeAway is? HomeAway, yeah. Okay, let's try this again. Who knows what Expedia is? There you go, yeah. So HomeAway is actually part of Expedia, and it's a brand that focuses on vacation rental market, and it's currently on a quest to assert its presence on this market. So we're doing this by investing a lot in digital marketing automation at the moment, and the goals of this are two. So we've got to automate, of course, repetitive tasks that are usually performed by human marketers. And second, we want to move forward and gain an edge on this human activity by minimizing errors and reaction times. So my name is Stefano. I do code mostly for HomeAway. And I'm going to show you how we tackled marketing automation, or at least one of its many phases, developing reactive pipelines with Akka and Scala. So the problem we're trying to solve is the following. We want our advertisements to be effective, as much effective as possible. So we want them to be dynamic, right? So we want to show relevant content to the relevant people at the relevant time. So let's assume, for example, someone was on HomeAway earlier today looking at some property in South Africa, reasonably priced villa, and it didn't book, right? So it could be a good target for us to actually show an ad like this to try and get him back to the site for completing the booking. Now, the key point here is that whoever displays this ad, whatever platform displays it, needs to be up to date with HomeAway data, right? So it needs to know about our properties, about our prices, and this data might seem static to you, but it actually can change a lot, especially if you think about the price. It can fluctuate a lot daily. There are exchange rates between currencies involved. So to make this ad effective, we want basically to get our data to these advertisement platforms, and we want to get it there as fast as we can. So this operation to send data over to advertisers to advertisement platforms is usually done manually, traditionally by marketers, and that usually involves something like sending like a big fat Excel file to some email address, hoping no one on the other side is on holiday, and that doesn't scale very well. So what we're going to do here is try and make this programmatic, right? So essentially, we want to set up automated feeds from us to the platforms. So this poses a series of problems. So first of all, the platforms is not just one. So there are many of them. What I listed here is just the most famous, but it's not a whole lot. And these are actually, they want different data presented differently, and they support different integration technology-wise. That's one side of the issue. The other one is, secondly, information on HomeAway side is actually scattered in many places. Within HomeAway, we've got a variety of data sources we need to integrate, and they come in different forms as well. So they can live in, Kafka feeds, under REST APIs, you name it. So this starts to become a fairly complex problem. So to tackle this, we need a pattern to roll out pipelines quickly. And we want our pipelines to be, first of all, resilient. So we want them to recover from failure, be always on pumping data to this platform. Second, we want them to be scalable. So, of course, we want them to handle changing and possibly increasing load in traffic. So in one word, we want our pipeline to be reactive, right? And indeed, reactive streams is what we went for. Okay, let's take a more practical look at how we tackle this problem. We're going to do this by example, and we're going to assume we want to build the following reactive pipeline. We have a Kafka feed of property data. So this, you can imagine this, the property details coming in. We want to validate or transform this data, do some processing, and we want them to send to Google AdWords, which is our platform. So this is a very simplified view of the AdWords feed we have actually in production right now. So how we structure the code in our approach is in 3 layers. So we have an application layer, a reactive layer, and the domain layer. We're going to check them out one by one and take a look at how they are made. So we can start by reasoning about the reactive layer, because That's the core part of our pipeline, and it's actually, so we're going somehow middle out in terms of design here. This layer actually makes the only opinionated choice of this sort of framework we're using, in quotes, in using Akka streams, which is a reactive stream implementation. And this layer responsibility is to use Akka streams to define the stages of our pipeline. And stage is actually a core concept here. It's borrowed from Akka streams as well. And it's essentially a reactive component of arbitrary complexity. It's reusable and composable. So they come in form of, as you've probably seen, sources, sinks, flows, or graphs, depending on the shape they have, and that is the number of input and output port they can carry. So it's important to note here that these for us are not just Akka streams DSL objects, but they became part of our ubiquitous language. So in other words, they went on and integrate our domain-driven design glossary whenever discussing pipeline implementation issues. So an Akka stage has got a type signature, and that's made up of, again, its shape. So these are input and output ports of the stage, and they're all strongly typed, plus one last type parameter that's called the materialized value. And that you can look at this as a stage interface, so something you can use to interact with the stage whilst the stream is running. We can have an example of these. We found actually it's good practice to decide these types for our stages during our analysis phase. So we want to let them drive the test and the implementation of our code. So let's first design the types of this sample pipeline. So we've got Kafka, we've got AdWords. We'll need, first of all, a source. And this is going to be, of course, a source of property. This is an entity we still have to design, but we definitely need a property entity there. And this one will materialize, as the last type is always the materialized value, to a shutdownable trait. Now, this is, again, it's a generic trait that we just think about here. It will offer a shutdown method, of course. And it's useful to interact with the source that Kafka provides, that you wrap around Kafka, actually, to control our Kafka stream, to basically be able to shut it down. This is useful, especially in tests, but it might be useful in production as well. So secondly, we'll have a flow. Flow is one input, one output. It will ingest properties. And here, as output, we've put a validated structure. So it comes from cats as well. So this is something that can be valid or invalid, depending on the outcome of the processing. Now, this can be modeled in different ways. I just wanted to put cats validated here, as I wanted to mention that we like to use cats to basically to define the types at this level to make our pipeline types as expressive as possible. So moving on to the sync side, this calls actually for a partition of the graph, because we again, we can have two outcomes of our processing. We could have actually a perfectly valid AdWords property coming out, or a validation error, right? So we just designed two syncs here, one to actually talk with AdWords for the happy path, and one to do something with the errors. Now here, as you can see, we're treating the errors as messages, as like perfectly valid messages in our pipeline. And this is a very good practice. It's not just only prescribed by the Reactive Manifesto, but it's also a very, very sensible thing to do, as it allows us to deal with all the errors in one place. We found it very convenient. So the last stage that we are having here is the graph, which is wrapping everything, is a stage with no input and no output, and it's just ready to be run, right? So we can note here that testing these single stages is way easier than testing the whole pipeline, of course. And this is also why it's very useful to partition your pipeline using this mechanism. So now we have defined the types, so we're happy with that. We want to move on to the code. So this is actually a good moment to look around for any library that might provide stages that does the job that you need. So I've listed some of them here. If you want to deal with HTTP, for instance, or TCP, you go to Akka straight away. There's Alpaca, which is ever growing now. to communicate with any source or any sort of third-party dependency. And if you want to deal with Kafka topic, then reactive Kafka is definitely a good choice. Now, this is exactly what we used in this example here. So here, this is basically our source. We use reactive Kafka, so we take this source off the shelf. And as you can see, well, we've wrapped this in an apply method. We put our type in the top, so we want the source to be a property shutdownable. And we use, you can see as it easy enough to, wait, let me just see if I can. Okay, well, basically, if you see this part here, the consumer.plain source is actually the reactive Kafka call. And easily enough, you can wrap your Kafka topic in a source of properties. The only missing thing here that you can see, I've simplified it a bit, is that you need to provide a deserializer, of course, to read your property instances. The thing is that this source is a source of consumer record, and it materializes to a control. So it's actually not a very good practice to leak these objects, these types outside of your stage. So what we do in the second part of the stage here is we actually basically make sure that the source is of our own typing. So we map the value to expose the property inside the consumer record, and we map the materialized value as well, wrapping the shutdown method of the control in our own shutdownable trait. So this way it's all sealed, and reactive Kafka only lives inside this guy. Now, moving on to the flow, this is the processing flow. Of course, this is not something we can get off the shelves, so it's going to be wrapping our domain logic. So we've defined here a property processing service that we haven't implemented yet. It's going to live in our domain layer. So this is where our business logic will live. So in this case, we just want to wrap in a very thin layer a synchronous call, and we use flow.from function here. So this is super simple. We just want to delegate this to our domain layer. The reactive layer doesn't do anything here fancy. So the property sync is equally simple as we define another domain entity called the property repository. So we're going domain-driven design terminology. And the difference here is that this repository will need to talk to Google AdWords, right? So we want it to be having an asynchronous behavior, so it will most definitely return futures. What we can do here at this level is we can use the map async combinator, and that will basically allow the reactive layer to limit the number of parallel calls that we make to Google AdWords at one time. So it's nice to see here how you can handle the reactive bit, so the parallelism configuration in this layer, and delegate the domain logic, the storing, actually the dealing with AdWords in the domain layer. So the last sync we see here is the error sync. So this is definitely a side-effecting sync. So we just want to ingest as many errors as they come, and do some logging, or register some metrics. This is just wrapping some side effect of choice. So the last stage is the graph. So this is where everything comes together. As you can see, we're actually passing in all the stages that we've seen before with all their types, and we use, in the bottom part of the slide, you can see we use the graph DSL, Akka streams graph DSL, to wire your topology in a very visual way. So using graph DSL sometimes is a bit controversial. So it, as you can see, is very heavy, and for this example, definitely it's overkill. But as your graph grows, this keeps documenting how your topology is wired, which is fairly awesome. So whoever looks at this should be able to clearly understand what's going on in your graph. And again, this is very similar to what we designed on paper a few slides before. So definitely it's very readable, at least in the bottom part of the slide. So moving on to the design layer. this is where your business logic lives, and this layer doesn't know about Akka, doesn't know about streams. We actually put all the business logic here. So the stuff we've got in here actually is been driven by the design decisions that we've made in the reactive layer. So we've decided that we need entities. This is on the left-hand side for properties, you know, AdWords validated properties, errors just for validation. We need a service to do the processing of these properties. This is all typed. This is already typed because we decided this type signature already, and the repository to deal with Google AdWords. Now, moving on to the next and last layer, the application layer. This is where a whole bunch of management tasks are performed. So config management, environment management, this sort of things. The wiring of the stages themselves. I haven't put the code here. This is fairly trivial. We need to wire the graph together here to make it run. Lifecycle management, important as we want to start and stop the streaming of data depending on the type of pipeline that we've designed. We want this layer to be responsible for restarting the stream in case anything very catastrophic happens. We want it to package the pipeline in a Docker container. And this is particularly important as Docker packaging allows us to scale even more as we can deploy as many feeds as these as we can in the cloud. So just to bring us back to why we were doing all this, we wanted these feeds to be, first of all, resilient, and here reactive streams enabling back pressure mean that the feed that we build cannot be overloaded, right? So this makes memory errors think of the past, and we've seen this by experience, plus any unpredicted failure results in restarting our stream. So these makes essentially our stream indestructible. Second, we want this feed to be scalable. So again, reactive streams can help us squeezing our local instances by minimizing resource contention, and this is because we use asynchronous non-blocking processing everywhere. But whenever this is not sufficient, we can easily scale horizontally in the cloud using Kafka and Docker. This basically can allow us to reach the throughput that we want, being limited essentially just by our integration dependencies. So, right, that was it. I really hope you enjoyed the ride.